Welcome to my newest LeetCode video where I just go through a random LeetCode question and solve it as if I was in an interview and talking through my process to an interviewer. Today I'm going to start off with a medium question and just pick a random one today. A random one that's not premium. Alright, and I like to time my attempts too, just to make sure in a real interview I will get them done in time. Let's start the timer and start reading. So this one is called swap for longest repeated character substring. So you're given a string called text and you can swap two of the characters in text. And we want to return the length of the longest substring with repeated characters. Well, okay, let me just write that down. So given a string called text, we can swap two of the characters in the text. And we want to return the length of the longest substring with repeated characters. Now, straight off the bat, we can see that the tricky part is involved with how we can swap two of the characters. Because if we couldn't do that and we just had to find the length of the longest substring, this would be pretty simple. Anyway, let's just go through these examples, make sure we understand. So in this example where text is A, B, A, B, A, we can output 3 because we can swap the first B with the last A or the last B with the first A, and that will give us a run of 3 A's. In the second example, we've got 3 A's, B, and then 3 A's. We can output 6 as we can swap this B with the last A or the first A, and then that will give us a run of 6 A's. And in the third one, we've just got all A's. We can output 5 because there's no need to swap anything, and we've already got a longest substring of 5 there. And our constraints, the text can be between 1 character long to 2 times 10 to the power of 4, and there's also only English characters. Now, I'm wondering if that English characters thing would help us at all, as that's an interesting constraint to have, but I'm not sure. Let me just think about it. Just think about some naive thoughts first and just write down whatever I comes to mind, just to get my thoughts onto the screen, onto the page. So what I'm first thinking is let me think. Just a random thought that's come to mind is, could we find the longest substring that has repeated characters except one. So for this example, we would get the whole thing as the longest substring that has all repeated characters except one character, which is B. And I'm just wondering if we can do something with that. Maybe we could maybe, I don't know, search the rest of the string first to see if there's a character we can swap the odd character out with. That makes sense. So in this example, I'll just go down here. If text was similar to this one, but if it was, say, something like this, well, our longest substring that has all repeated characters except one would be that. And then, oh no, sorry, just that. And then my idea was to maybe search the rest of the string first to see if there's a character we can swap the odd character out with. As in, we're looking in the rest of the string first to see if there's any occurrences of the main character in our string here, so the A. So we're looking for an A in this gap, really. And we've got one here, so we can swap that with our odd one. And that gives us the correct answer for that example. But if there isn't any, so I'll just put that back. If there aren't, I should do this actually. Any occurrences outside or in the rest of the string. Any occurrences of the dominant character in the rest of the string, what we could do is just swap our odd one out with an element on the end, on either end. Swap odd with the dominant character on the end, on one end, if that makes sense. So in this example, we again have this, that, and we're looking for A's in here. There's no A's, so what we just do is swap this B with either the start or the end A. So what that will do is that and put that there, and that will give us the correct answer for that example. Let me think if there's any times where this wouldn't quite work. You know what, I'll try it with this example too. So first we see the longest substring in this that has repeated characters except one would be that'd be the first one we'd find. Otherwise it could be that one as well, but we'll go with the first one that we find first. So now we want to search the rest of the string to see if there's a character that we can swap that B out with. Oh, we see there is. So we want to swap that A with a B and the B with an A, and then that gives us the correct answer. Alright, so at the moment it's looking promising. Let me think if there's any other times that this could mess up. What if we had, oops, I don't know, if we had something like this, just to be interesting. So we'd go through, find the longest repeated substring that has repeated characters except one. The first one we see would be this one with the 5 A's interrupted by 1 B. So now we want to see if we can swap this B anywhere outside the string. We can't, so all we do is swap this B at the start or the end. Now this looks interesting. If we swap it at the start, we get a different substring B's, but so if we swap at the start, this is what we get. Otherwise, if we swap it at the end, we would get this. Now the solution here are these A's again, which is 5 A's long, and over here it's 5 A's long, and these B's are also 5 B's, 5 characters long, so we return 5 either way. So it seems that this should work so far. Struggling to see an example where this wouldn't work, but anyway, let's just go. Let's think about how we actually find the longest substring that has only one, has repeated characters except one. How exactly we could do that? Well, think. Because we also have to keep track of the indexes, just so we know sort of the window. So I guess we could do a sort of sliding window / 2-pointer approach, maybe, where we just start 2 pointers at the start, and just if it's a consecutive character next, or it's the first mismatch we've seen, we can move our out pointer. I'll write that down. So 2-pointer / sliding window. Start left and right pointer at 0. And then if text r+1 equals text L, or it doesn't, but it's the first mismatch we've seen. I don't know if that's a great way of explaining it. Then we just increment R. Else if text r+1 doesn't equal text L, and we've already passed one mismatch, we don't increment R. And left to R gives us our window. So that gives us, we just have to keep track of the largest size. That will give us just the first one. So in this example, that should give us ABA. In this one, it should give us the whole thing. In this one, it will give us the whole thing. But there's also another problem where if the text is, say, AAAB, we would return that when we don't want to. Which I'm not sure if that really matters, because all that would happen is we just swap that B with itself or with the start. So I'm not sure if that really matters. But anyway, we need to keep track of the maximum as well. So how could we do that? I guess we could keep track of a max length and I don't know, a pair of max pointers. So we would do this, and then left to R gives us our window, and then we would just check if our take left is greater than our max length. Then we just set our max pointers to be equal to left and right. And then after we've done that, we want to update our left and right pointers. So we'll just set, what would you do? Would we set left and right pointer to, oh yeah, where would we set it to? I'm just trying to think. If we just want to save some time, so we don't have to just increment it by 1, as in start our search from here, and then after that start from there. What we want to do, I think, is maybe start from there. I'm not sure if it will hurt our efficiency too much if we just start from the next one there. How would we do that anyway? I guess we could do that, and we can always optimize that later. And then we'll just update left and right to previous our previous L value plus 1. I guess that should work. So after all this, we should have a pair of pointers that point to our max substring that has all repeated characters except one, as well as the length of that one, and then from that we can search the rest of the string and see if there's a character we can swap out with. Otherwise, swap it with that, with one at the end. I guess, yeah, after we've got our max window, we can just go through it again just to note the index of the repeated character. I mean, we could do it. We could store that here, but I think that's just a small optimization that we can do in a bit. So let me think of the time complexity of this approach, this sort of possible solution. So to search the string for the longest consecutive sort of string, repeating character string, substring, you know what I mean? Well, I think if we do it like this, when we only update left and right to be previous L plus 1, then it would be big O of n squared, because for each n, we're searching the rest of them. So there's definitely an optimization here that we could do, maybe to get it done in one pass, I'm not sure. But at the moment, it takes n squared time to find the longest substring with repeat characters, and then to search the rest of the string to see if we can swap a character. Otherwise, to swap the other characters, that would just be big O of n again, and the rest of those inside operations are all constant. So this would go to an n squared solution, I think, where n is the size of text. Space complexity is constant. We only have to store sort of our pointers and our sort of constant variables. So before we move on to coding, I'm just going to double check if we can hopefully improve our n squared time here. It worries me a little bit. I think, yeah, my bottleneck is finding the longest consecutive substring. Let me just go through some examples why we don't have to just update L and right by L plus 1. So what's a good example? Maybe if we've got A, B, I don't know, maybe. So we would go through, I'll just illustrate my pointers. So that's left and right pointers, so we start there, and we also want to keep track of max length, just so we can see. So we start here, max length is at 0 at the start, of course. You see that R plus 1 is equal to L, so we move that along 1. Now our max length is 1. We move on to that first B. We see that it's our first mismatch. However, so it's only our first one, so we can still include that. So that's equal to 2. Now this second A, with A after that first B, we can count that. So it's equal to 3. And now we can't count that last B. So this is our max length, that's 3, and that's our window. I think this is not the best example, so let me go through another one. Maybe if we did something like that. Yeah, I think that's a good example to do, to point out where I'm thinking we might be stuck at. So at the moment our max length is 0. We move our right pointer to that first B. It's 1. It's the first B we've seen, but we're on A's at the moment. We move to the next one, that's an A, that matches our left pointer, so we increment that by 2. Then again, we've got another A, we increment that by 1 again to 3. And now the next one there is a B, so we can't include that one. Our max length here is 3, and our max point is 2, I should include. At the moment, 0 and 1, 2, 3. Yep, 3. Actually, no, that should be 4. No, sorry. Our max length should be 4 because 1 character means it's 1. That's my mistake. Anyway, so our max point is a 0 and 3, but that's not the correct answer here that we want to get here. So maybe we want to start our left pointer from the first mismatch, maybe? Maybe. Well, let's do that then. So I'll move this down here. Well, we can go forward 1. It's a mismatch to the B, but we can do it once. And again, so for this one, our max length is only 1. So then we would start from the first mismatch here, which is that A. So I'll just do that. And then starting here, we should get our optimal solution. So we've got this A. I'll also just copy this. Let's move that as well. So our max length is 4 before, and our max pointers were 0 and 3. But now we want to go and start here. So we will need to keep track of the position of the first mismatch too. Anyway, we are here, and we start at this first A. We move R plus 1. As we can see, the length is now 1. And then we go to B. It's our first mismatch. It's 2. The next A is 3, and the last A is 4. Oh, and sorry, we should have started at 1 and A, as I said before. So the length of this is actually 5, which is bigger than our max 5. So our pointers can actually be improved to be 2 to 6. Yep. Yeah, that looks correct. And then that's our max pointer. So we also want to actually store for each iteration of pointers the first mismatch. So I guess we just want to I don't know, have a variable to keep track of first mismatch position, increment R, update first miss position, and then we would actually update ln R to first miss pos. Now, does that improve our time complexity actually? I don't think it does asymptotically, because if we had something like A B A B A, we would start at A, we would go there, and then we would do that, and then we would do that, and then we would do that. So it's not great. I feel like I'm definitely missing something out here. So I mean, before I commit to coding this one up, I'll think again if there's any possible other approach we could do. It's definitely this is the bottleneck, the finding the longest substring. I'm not sure if there is a possible way to get that down. Maybe we'd have a chance. I'm not sure. Well, we'll code this up for now, and then if I don't think of anything while coding it or after coding it, we can have a look at some of these hints and see if they help. So anyway, let's just code this one up. So we'll do our main comments first. So we want to find the substring with at most one with repeating characters except at most one. We use 2 pointers, so we will just do int left 0, right equals 0, and we'll do that on different lines just to be more readable. Length equals starting at 0 for now. It will be 1 at the minimum every time there. And we also want a pair of max pointers. That's not how you do that. Which we just start at 0 for 0 for now. And we also want to, oh, we don't need to keep track. We don't need to initialize our first mismatch position yet, I think. Maybe. Either way, we will just do while R has not gone out of bounds. Text size. We would do maybe, I don't know. No, I think actually, I'm trying to think when we would set the first position, the first mismatch. I don't know, we'll have it up here for now. And then we can move it if we need to. So what do? We want to keep track of our max length thingy, and then we just do if text r plus 1 sort of exists, and if it equals L. And we also have to make sure this is our first one we've seen. Maybe we can just have a Boolean tracker. Sure, that's not the right place to put it, but that's all right. And found. What we would do is increment R, and if it was a mismatch, hold on, I've done this in the wrong. No, so I'll add comments. If the next character matches text L, we would just increment R. We would we don't have to do that yet, but we can just increment R there. Else if text R plus 1 exists, so maybe we can make that minus 1 after, but I'll just stay with this for now. If it doesn't equal that, and the mismatch has not been found, we can still R plus plus, we can set mismatch and equals true, and we can set the mismatch plus equals R plus 1. Alright, and then what do we do? Is there any other case? Not that I can think of, but now we just want to update our maxes. So we just do if R take L plus 1 is greater than max length. We would set max length to R take L plus 1. We would also set our max pointers to be right. Is there anything else we need to do? Just trying to think if this is when we want to do this, or if that would be like an else. Maybe. I think if we just remove that, it makes it a bit easier to read. So if the next one is L, we just increment it. Else, if it's not L and we haven't found a mismatch, we can increment again. Maybe it's else again. We'll update our maxes, because that means we're at the end. We've got our complete window at the end there. And then we update maxes if we need to. And then after that, we set mismatch found equals false again, and we set left and right to first miss plus right. I think so. Equals first mismatch plus, and the same. I'm not sure about this, but update variables for next. I'm not sure if this would work. Hopefully it does. I'm not super confident on this one at the moment, but then we have to do the rest of it. So we have to search the rest of the string to see if there's any character we can swap the odd character out with. So now, at the end of this, our first mismatch pos is the one we want to swap. I'll just write that down. Is the element we want to swap in left right window. So I guess we can do for int I equals 0, I is left less than left, I plus plus, just searching on the left side, so the left side of the string. If we have to also make sure we're checking the dominant sort of, which is just L, yeah. Alright. And also this should be update actually, so in L equals max pointers. I think it's first, I think that's how you do it. Second. That just makes it easier for us to keep track of left and right. So if I start from we're searching to the left of our max substring. So just go through each one, and if it's equal, so yeah, if text I equals left, oh sorry, text left, then we could swap it, and I guess then we can just instantly return left plus 2, I think. Can instantly return the new if we swapped. We don't actually have to swap them, we just have to return the length of the longest substring if we swap them. So we just go through that, and then I guess we can go through, I'm just trying to think if that's the best way to do that. Let me think of another example before I lose my lose myself. So in this example, we would get this, and so we'd want to swap that B with there. Oops. So I'll just copy that so we can see. So we would swap that B with the first A, so that. So we would get 5 there. Oh, so it's not L take R plus 2, it's just the same thing, plus 1. That means we can, I guess otherwise if we never find one, it would just be R take L, right? Is there any other case? And then, ooh, we do have an issue if, well, no, our longest substring one that only doesn't match, that only has one mismatch, we'll never have the mismatch at the start, as far as I'm aware. The mismatch will be in the middle or at the end. So this part should be right. We'll have to be careful when we search for the second half. Text for the substring. After the substring. This, I feel like this is definitely not the best answer. It's very long-winded. But we'll just continue. So I equals I think R plus 1. I is less than text size. So I guess if we do find one, we can return. Otherwise, if we never find one here, something else happens. We'll do the main stuff first. So if we do find one, I equals text L, which just means that I think it should be fine. Dear. So if we had this example, let's just better swap those ones. So, because that is actually what counts. That's what we would have in our window. Wait, no, it's not. Sorry. Let me just remove the rest of this stuff. So in our window here, we would have that. And then, so we just want to search through there. If we can return the length. Okay, which is just that. Otherwise, if that's not there, we have to return the length take 1. So if nothing ever gets found, I guess we would just return R. I'm very not confident in this. No swaps can be made. Let me double check as well. Hold on. If B was here, all we would do was swap the A. So the length of that is currently 6. We'd have to swap that B with the, oops. The length is currently 6, but we would have to swap that B at the end, and now the length is 5. So it'll just be that. I'm very not confident in this, but let's just run the test, see what happens. Hopefully we can save it. First mismatch pause. Where have I done that? Mismatch. Whoops. Oh, yeah. Don't need to do that again. Alright. Alright, well, we get the correct answer for those ones, which is interesting, but not for this one. We output 1, which is interesting. Okay, so we've got the first 2 ones that look to be correct, but not the third one. In a real interview, actually, before I sort of submitted it, I should have tested it by hand. I mean, it's LeetCode practice, so it's not too bad there. Let's just go through what happens here in our, what we've got. We can do that just by adding a note there. Whoops. So if you've got our text equals 5A's, and we just go through here, so we start our pointers there, and r is less than text size. Yep. If text r plus 1 equals text l, oh, I think I see what happens. We would increase that to the next one. Yeah. Okay, and then so we would do that over and over again, and then we would never even update these. So then we would just fill out. So maybe that doesn't need to be an else. I'll just see what happens if it's not an else. That means we should update it each time. It's only this when we're here is when we mess up. Actually, so if I keep that else and actually just update the maxes. I don't know if this is the best way, but oops, update the max there, and then else we would do that. Maybe I'll run that just to see what happens. All right, well, we've got accepted tests. I'm not super confident. Let's just submit it, see what happens. Yeah, not good. But now we've got a test case that we can use. We output 4 when it should be 6. All right. Now why did we get to 4? Because we should get that in our window, and then just swap that B with the start, and that would give us 6. So our problem might be in our longest substring finder. So what would we get? We would get to there, and that would be our first window we see, and then we move there, we would get that, and then we get there, and we get that, and then we should go here and get that. So I'm not sure why it's not worked. Let's just do some testing and see if that is where we've gone wrong. So let's just see out. Let's not be fancy. Let's just do just the left and right pointer values. I was going to maybe output the actual substring, but I think that's just a bit too overdoing it. Wasting time doing that. So what do we get here? There's 7 and 10. 0, 1, 2, 3, 4, 5, 6, 7. What? I counted that wrong? How have we got 7 and 10? 0. Oh, yeah, sorry, that's not meant to be that. That should be max pointer. Max pointers, was it? Yeah. First. Max pointer. Second. That should give us 0, 1, 2, 3, 4. Should be 4. 0 and 3. It's not what we want. So why has that happened? Why has that happened? That is very interesting. Why have we got our max pointers ended up here? Do we ever quit early? Is that an issue? I'm just going to do some more cout testing. Okay, so for everything we just do, oops. Just look at the current left and right pointers. Whoops. go, sorry. Just to see how we're iterating. Maybe we quit early or we've done something wrong. So we go 0 to 3, and then we go 3 to 5. Hold on. So the indexes that we're looking to get, 0, 1, 2, 3, 4. If you start at 4 and go to 5, 6, 7, 8, 9. It should go 4 to 9, not 7 to 9. Okay, this is confusing. I don't know why this isn't working. It's all in this big while loop, though, it seems to be. Do we update the max in here as well? Well, this feels like it's the wrong thing to do there. Just having that update maxes everywhere. I'm just going to Hail Mary, see if that improves us. Hello? No. Why is this not? Let's just go through what I think the code should do at every step. So we've also got our link starts at 0, and we've got pointers start at 0 and 0, and at 0 at the start. Well, we'll have it be empty when we haven't found one yet, just so we can do that. So, and we've also got our left is there, and our right is like that. Let's just go through this step by step. Oh, it annoys me that it's not in line. Oh, sorry, hopefully you can see that. So we start at left and right. Also do, oh, do we need to keep track of a current length? No. Well, our current length is that, so we'll keep track of that. At the moment, it equals 1. We move right down 1. We see that it matches the left pointer, and there's no mismatch, so make that 2. Now we go to A. We do have a mismatch at 0 and 1, mismatch position 2 there. Length we can still increase. Oh, there's an issue. We're incrementing R and then setting first mismatch to R+1. We should either do that first or just set that to R. I'm just going to run that, see if that was the issue, otherwise we'll continue testing. Looks like it may have been the issue. Why don't we submit this and just hope for the best here. Cool, 58 out of 60 test cases. That's annoying. Oh, that's going to be annoying to see the issue here. So actually in this example, we outputted 3 when we expected 4. So why should it be 4 and why did we get 3? Let's see if we can just work it out why it should be 4. It should be 4 because we've got this A sets of A's here and we want to swap that C with the A. Ooh, that's interesting. Yeah, I think that issue. Okay, let me just double check why we got a 4 as well. I'm guessing we get 4 because we use those C's. I'll double check that actually by just printing out the max pointer. So if we just so I don't go down the wrong path. Sorry. L is that. And R is that. I expect this will give us 0, 1, 2, 3, 2, 6. Yeah, so that's where we've messed up. So when it's at the end, I'm guessing are the 2 wrong answers. I mean, we could hard code in sort of that case, because that's happening because we're considering that to be a mismatch. Do we even consider these? What index numbers are these? It's hard to count. 0, 1, 2, 3, 4, 8, 9. So do we ever consider 7 to 9? We do. Okay, so how could we even hard code this in? Oh, that's really annoying. Oh dear. Wait, why do we even output? Oh, we output. Oh dear, yeah, that's why. Oh, I don't know how to fix this little tiny case. I guess we could just add an extra character onto the end, maybe? And then like that would be the one that we've considered swapped. I mean, I'll try that, and I'm just curious to see what would happen. So if we just do text push back, and then so a character that won't be involved anywhere can just be an uppercase English character. I'm just curious to see what would happen there. I think that I feel that could work. Why hasn't that worked? Let me think. I would have thought that would start testing that, and then I would have thought that that would get that, and it's different. Oh, that's annoying. Why doesn't that work? Let me see if that even gets considered. I would have thought that could work. Oh, I guess it's because it's equal. As in, those A's are equal. We consider them, but as the length is 4 is equal to that length is 4, we miss it. I guess maybe we have to keep track of when there's 2 equal ones. Damn, this is annoying. I'm just curious if we just make these greater than or equals, we would take the last one in this case. I'm curious if that messes up any earlier ones there. I feel like it's not going to submit some earlier ones, however. I mean, I'll try it. I don't really care about my submission percentage. Yeah, 2 more cases because now it messes up. Ooh, that's annoying. So our problem now is when we've got more than one substring with 8 characters, except one. I really don't know how we can sort of. I guess we could use a vector and just put the max set of max pointers in there. I mean, I'll try it. Could help us somehow. So be a vector of pairs. And we'll just call that max pointers. Just push that. No, we don't push that there yet. So when would we do that? Ooh, that messes us up anyway though, because when do we push it back to the vector? That's my question. I guess here maybe. Could be right, could be wrong. I'll try it. So we just want to push back max pointers. That's not going to work every time though. Because yeah, for this example, we'd never get here. We'd have to do that somewhere else. Maybe we could just do it again at the end. I don't know. It's really horrible code now. In a real interview, I'd be hoping that I get points just for my having a creative thought process. I don't need comments for that one. So now what we actually do is just to report 0, j is less than max pointers vector size plus L equals max pointers I dot first, second, and that would be R, and I guess we can just squish this in maybe. Do we need a max maybe? Right. Yeah, this is really ugly code. We want to keep track of our max length though. Let's go max. Oh. Max L equals 0. Now we would just set L equals that. All these ones. No, not that. We can actually just do this. Maybe. I think that might give us some sort of hope. And then after all that, we just want to return. I have absolutely no idea if this is going to work at all. I just want a Hail Mary. Ah, yeah, it's J. Of course. That's all good and fine and dandy. Still mess up there. That's what we were trying to avoid with this whole approach. Oh, we also need to do, yeah, this. Not sure if we need the equals everywhere there or just there. Oh, we've got a email. Sorry. If this looks promising, I'm just going to submit it and just hope for the best again. We've done it. Oh my goodness. I can't believe that actually worked. And it's decently fast as well. Very over the top, sort of very complicated approach here. But it's worked and it's decently fast and it doesn't use too much. That's very interesting. I think in a real interview, if I did that in half the time that I've done it today, it wouldn't be the best, but I think it'd be fairly good as it sort of shows your thought process and stuff. I think my thought process there was mostly coherent and easy to follow. Not sure if I used the best practices in coding things though. So hopefully you understand this solution. I'll go through some, look at the optimal ones in a second. But yeah, hopefully you understand this solution that I came up with, which was to just find the longest substring with repeating characters that have at most one mismatch through this long-winded loop, And when there's also equal substrings, in the case where there's equal substrings with at most one mismatching loop, we place them in a vector. And we also push back this a at the end just to ensure we count the last anything at the end. That's so over the top and confusing, it's so bad, but it works, which is good. This will go through. If the next one is equal to our characters we're looking for, we just increment it, and if it's a new max, we update our max. Maybe we don't even need that there if we've got that end thing. I don't think we do actually. I'll move it and see what happens. I'll just run it again. Okay, so yeah, we don't need that. Do we need this one? Yeah, I think we might need that one, but I'll test it without it. I'm not sure about, oh, I mean, I'll try it. I mean, that makes it a lot easier to read without that one anyway. Oh, it does work. Apparently it's slower, but I don't believe that. Okay, yeah, so if the next one is the character we're looking for, we can just increment R. Else, if it's the first mismatch we've found, we can mark that. Increment R and also store our first mismatch position. Else, if it doesn't match and it's not our first mismatch, we store our max length if it's the longest we've seen so far, and we push it to the vector as well for later use, and we reset our vectors and we start the left and right pointers again at the first position that we found a mismatch. And then so if we never find any mismatches, we would only end up looking in this place. So an example would be this one, I think. We would only end up looking there, so we'd have to go through and we would never even touch these parts, which is why we would just need to push back what we've got at the end anyway. I think that in some cases that will give us duplicate values there, but that should be fine here. Anyway, and then so we want to find the max length we can get by swapping the mismatched character. So what we would do is we just go through each pair of pointers that give us the max window so far in our vector. We just go through each one, and we want to see if we can swap that mismatched character with any other character outside of that window. Actually, I'm just wondering if we can make a swap, we can instantly just return. All right. I think we can. Let me just, yeah, do that then maybe. Just to test and see if it works. Could we just do that? Well, I'll just store it in this variable for now. I feel like that might work. No. So what have I done wrong there? Oh, I'm not sure. I'll just fix what I had before. That's weird. I would have thought for each pair of pointers in the vector, this value will always be the same if we can swap it. And then if we can't swap it, we'd get here. Well, I'm not quite sure. I'm just going to stick with this one for now. Yeah. Oh, that's a bit weird. If anyone knows why that is, feel free to leave it in the comments. But yeah, hopefully this makes sense. So we just go through for each set of pointers in the vector. That represents a window that has at most one mismatch. And then what we do is just for each one, we want to search through the rest of the text before the substring. And if we can swap that mismatch with any of those characters, then obviously we can return that length. But in this case, we want to keep track of the max for some reason. I can't quite think why we can't just return that early. That's alright, we'll just keep going with that. And then the same thing on the right side as well. Alright, I think that's all good. Let's look at maybe some better solutions. So much shorter already in both of them. So what they do is a sliding window as well. So for each character within a string, they use the sliding window to set the longest substring up to 1. Note that the result will be the minimum of the longest substring and the total number of characters. Since we may not have an extra character to swap, this time is bigger n times m, where m is the number of distinct elements, and constant memory. Now this one's group and count. Instead of going through the whole string 26 times, we first collect indices for each character, and we process each character and use its indices to determine the longest substring. In the solution below, we count the number of consecutive indices count and track the number of previous consecutive indices count 1. Note that we set count 1 to 0 if the gap's larger than 1. In the end, we'll get a max count of the repeated characters with no more than 1 character gap. If we have more of that character somewhere in the string, we add 1. That's a bit confusing. Curious why mine is so over the top bad. I'm gonna ask ChatGPT if it can improve mine a little. I'm just curious to see what would happen. Alright. Got a solution to the LeetCode thingy, but it is very I don't know. I just think it's very poor code. Please improve the code. Here it's let's go here. We don't need my text at the bottom. I'm just curious what it gives. Alright, so they kind of, I mean, ChatGPT kind of fixes it to be the actual good solution. Alright, let's see if that actually works. So just curious. Oops. Hold on. I'm just curious if this will run. I doubt it because it's ChatGPT, but it might have gotten close. No. Alright, see if we can understand this solution. So I'm just going to write it out line by line. Hopefully I can understand it and talk it over. So we want to go through each character in the text called we want to go through each character in the alphabet. A to Z. Okay. I don't think it really matters how you increment it like that. And you want to set our, I guess I and J are the pointers maybe. 0, J equals 0, and our gap equals 0. Now we just do while I is less than string.size. Yeah. Alright, so it's also called text. Gap plus is equal to gap plus string plus plus if it. Hold on. That is an interesting way of doing it. So they go through each character and then they want to go through each character in text. So if I think they've just tried doing it too use as little lines as possible. It's not very readable, which is annoying. I'll just write the whole thing out now. It's just result max result min j. Oh, these count ifs. See, like, what the heck is that? That's not very easy to understand. I'd assume most people. Let me see if I can find a slightly more intuitive solution. Whoa. So what does this one do? This one goes from the left and the right. It's another very convoluted approach as well, like mine was. Actually, you know what I'm going to do is use the tools I've got. I'm going to ask it just to add more comments to this one. Ask ChatGPT. So I've got a solution to LeetCode. C++. Please improve the readability of the code as well as adding lots of descriptive, which is always good. Just put that there. Right, I haven't really changed anything, but hopefully this makes more sense, and then hopefully I can understand it as well. So we want to, of course, iterate through all lowercase letters. Hopefully you can read that. Yeah, you should be able to see that. For so A is less than equal to Z, and we're just incrementing it each time. It doesn't explain what I, J, and gap is. I'm guessing it's the pointers. Zero. So we traverse the string on the longest repeated substring. Okay. Not the most helpful comments yet, but hopefully improves. Count the gap between consecutive characters. Character check. So how does that quite work? I think having that I++ in there just makes it a bit, it's just a bit unnecessary, makes it a bit harder to read. I'll put it in now, and then I'll try and fix it up. Just make it a bit more readable, not fix it up. The gap exceed 1 with the, I've never seen anyone use J as the left pointer. Let's go to 1, we'll just do gap. J plus text. Whoops. Text, if it goes into that. And then we want to update the result with the max length of the repeated substring for character check. Oh, I forgot about this. I'm going to ask it to expand. Please expand this line. That's not what I meant. I meant expand. Readable. Alright, I'll double check this works before I commit to it. Oops, too much. What have I done? And I'll just double check that, yeah, that this still works after doing that. It does not, because that needs to be text. Where have we got? Oh. 0. Alright. Alright, so this seems to work. So let's see if we can understand it. So we want to update the result with the max length of the repeated substring for the current character. So first we want to count the occurrences of character in the string, which is the COUNTIF function, which I never really used. And so what that does is just count the occurrences in the text between the start and the end where this is true. For each character where this is true. So that just counts the occurrences in the string where a character in the string is equal to the current letter that we're looking at. Which is pretty simple logic. I just never remembered to. I never think of that function, to be honest. And then so we want to calculate the length of the current substring with the repeated character, which is I take J, which is pretty normal. And then we want to take the minimum of the length of the substring and the count of occurrences. Guess that makes sense. And then we want to update the result with the maximum between the current result and the new calculated minimum length. This part is interesting. I'm not sure why it's like that. So the minimum of the longest substring and the total number of characters is the result, since we may not have an extra character to swap and close the gap. It's a bit confusing. Hopefully you guys understand that, because I barely do. I might need to come back, do some more study on this one, but let's just submit that, see how much faster it is. Actually no, not much faster, but it uses less storage. That is weird. Let me submit it again and see if that was just like a variance. That's weird. I wonder how fast my solution was then, if it's half the speed or if it's just nothing. Alright, so let's look at this group and count. This is kind of the one that matters more because it's faster in time, but to be fair, it uses more memory. So let's just put that in there. For now, make sure it works. And also, oops, let's tidy that up a bit. Instead of just trying to squish it onto as little lines as possible, which everyone on LeetCode loves to do, I think it's better to make it actually readable. That and there. Oops. There. Looks right. Let's just run that, make sure I haven't messed anything up. Alright, let's ask Mr. ChattyGP to add some more comments to this. So what does it say to do? There we go. So yeah, initialize the result. That's pretty simple. Create vectors to store indices of each character in the text. Alright, that's interesting. And then we want to populate character indices with indices of each character in the text. So what does that even do? So let's just read through this again. So instead of going through the whole string 26 times, we want to first collect indices for each character. And then we process each character and use the indices to determine the longest substring. I guess that's so in the solution we count the number of consecutive indices. Okay. And then track the number of previous consecutive indices. I think that makes sense. Let's just keep going there. So now we want to iterate through each character A to Z. Each character A to Z. Initialize variables to track counts and max substring rate. Let's actually change this to, yeah, those are pretty poorly named variables, I think. So consecutive count, and we've got our current count, and we've got our max substring length. So now what we want to do is iterate through each index of the current character. So just yeah, I'll just change all these around too. So our indices, so it's just one to the through the whole thing, and also this just so it's more readable. So check if the current index is consecutive to the previous index. Pretty simple. Increment count, which that one is current count, if I recall. Else, if the current index is not consecutive, update consecutive count. Yep, which is that one. Count, and I think this one was current count. Hopefully, so what this line does is updates consecutive count if the the current index is equal to the previous index. Is that right? Plus 2. Oh dear. That bit's just a bit confusing. Well, we'll continue. Probably not the most helpful solution breakdown, but we'll keep going. We'll reset the count, and then we want to substring length seen so far, which is just that. Count 1, I think, was count. Count was current count. And then we go down here and we update the longest substring length with the for the current character. So it's still called result. This one's still called result. Yep. MX is max substring length. Track to me. Let's double check we haven't messed anything up. Let's just submit it to make sure it works. I'll go back through it one more time. I'm going to submit that again just to see what the time says. Why is my submission so much better? Was it a coincidence? Or what? I think it's just LeetCode being LeetCode. So this solution's pretty confusing for at least me to understand. So we create a vector of vectors to store indices of each character in the text, and then we populate them with the indices of each character in the text. Yeah, which makes sense. So for each letter, we've got their indices in the text. So we come down here, and so we're going through each letter, and then we're going through each index of that character. So if the index is equal to the previous index plus 2, so if there's one gap, if there's a gap of 1 between it, then I guess something different happens, because you can fill it in. Oh, and then it equals current count, otherwise it equals 0. Okay, that makes sense, I think. Let me just update that. Alright. I'm gonna be honest, I barely understand that solution. So I'm sorry if I haven't explained that very well either. Hopefully it's made it a little bit more clear for some of you. But hopefully you enjoyed watching me struggle through solving it for the first time by myself for an hour. I mean, I'm pretty happy with that, even though it took twice as long as I want these mediums to take. But I'm happy we got an answer in the end there. Quite complicated, overly complicated, but we still got there. If you enjoyed the video and you'd like to see more, definitely be sure to leave a like and subscribe and comment any feedback you have. It really lets me know that I should keep doing these videos. Yeah, and yeah, if you enjoy these videos, I'll keep making them for a good while at least. I've still got to do my LeetCodes every week, so might as well make a video out of it, you know. Alright, well, thank you for watching, and I'll see you in the next one. Alright.